This is a Math 1 lesson summary video for the task titled Making More Money. This is a Solidify Understanding task. The purpose of this lesson is for students to estimate a correlation coefficient in a line of best fit for a data set, and then compare the estimates with the correlation coefficient and linear regression line calculated with technology. In this lesson, students will also interpret the slope and y-intercept of a line in context. Each year, the U.S. Census Bureau provides income statistics for the United States. In the years from 1990 to 2005, they provided the data in the tables below. All dollar amounts have been adjusted for the rate of inflation so that they are comparable from year to year. I went ahead and took the data set right here, the median income for all men, and I have typed it into Desmos. Now that I have all my data listed here, I still can't see it on my graph. And there is a Zoom Fit button right here on Desmos, so Zoom Fit. And now I can see my data, and I can grab the screen. So the first thing I'm going to do is estimate my correlation coefficient. I think my correlation coefficient is going to be somewhere around 0.7 or 0.8. I know that it's positive because I can see here as the x value increases, y is also increasing, but it's not very strong because it looks very strong here, and then you have this little bunch of data here that goes up and then comes back down. So that's really interesting to think about what was happening in those years. All right, so it's still pretty strong, but it's not very strong. So I wouldn't consider it weak, but I wouldn't consider it perfect either. So that's why my estimate is somewhere around 0.7 or 0.8. And we'll calculate it in just a moment to see what the actual correlation coefficient is for this data. All right, the other thing I want to estimate is a line of best fit that would fit through my data. So I'm going to just come over here to a blank entry bar, so I could put the plus and hit expression. And I'm going to use slope-intercept form, except I'm going to start with my y-intercept. Because if I start with my y-intercept, let's see, if I put it at, if that's 36,000, 37,000 would be right here. I can see where that value is, 37,000. I think I might want to increase it just a little bit, about 37,500. And now I'm going to work on my slope. So if I put a slope of 1, that's very flat. If I'm looking at how these data values are changing, it looks like it's changing if I go from 1 to 2 to 3 ever so slightly. If I put in 1,000, that's way too big. So let me try 500. Still a little big. Let me try 300. That's more like it. I feel like this line kind of goes through the center of the data. So now let's use technology to compare the line that I estimated with the actual line of best fit. And to do that with Desmos, I have to type in a specific command. So I have to look at what my variables are labeled here. I have x1 and y1. So I'm going to use slope-intercept form. I'm going to do y1, then I'm going to use the tilde, so shift and then the button beside the 1, and then m for slope, x1 because I want it to use the x1 variable, plus b. And what that does is it calculates a linear regression line, and it tells me some information here. My parameters m and b, so here's my slope, and here's my y-intercept. So I had estimated 300 for the slope, but the linear regression line gives me 311.661. I had estimated 37,500 for my y-intercept. The linear regression line gives me 37,629.7. And right here is the correlation coefficient, which is close to my estimate. So I have 0.7928 as the correlation coefficient, which indicates that I have a strong positive correlation between variables. So now let's interpret our values, our parameters right here. This data is giving me median incomes for males between 1991, this is 1991, and 2005. So that means my y-intercept right here would be year 0. So this would be an estimate for the median income in the year 1990. The slope, this 311.661, that, remember, slope is rise over run. So every time that the year increases by 1, the median income increases by $311.66. So to recap the technology that we've gone over here, if you want a linear regression line, after you enter your data, pay attention to what your X and Y's are labeled as. This one was X1, Y1. Then type in, since mine was labeled Y1, I put Y1 and then I use the tilde. You can find that button by using Shift and then the button to the left of the number 1. So the tilde, and then M for slope, X1, because this is labeled X1, if it was labeled X2, you would write X2, and then plus B for the y-intercept. This created this blue line, which was fairly close to my red line that I had estimated, but it created this blue line, so a linear regression line, and it gave me values for M, the slope, and the y-intercept of the line. And then R, right here, is the correlation coefficient, which gives me information about the strength and the direction of the correlation between my variables. Alright, that's it for this video. Thank you for watching.